Okay, on the first one, I just divided the budget by the citizens up here. And for the estimation, I rounded the first numbers of the scientific notations to 4 and 3, and just did 4 divided by 3 for the first number, and then subtracted the exponents over here. And then on the actual, I did the same thing, except I didn't round up the first numbers, and I just used a calculator and divided 3.77 by 3.20. And then on the second one, I did the same thing, just of course with the different numbers, debt instead of budget, just divided those. And up here, I just, like I said, just rounded up and divided that way, and then down here I actually used the real numbers in the calculator. Number 3, I just did what I know to do for percentage, which was divide the education allocated, which was $141 billion, divided by the budget, which was, I forgot what it said, but the scientific notation is 3.77 times 10 to the 12th. So I just divided those, and I did the exact same thing I did up here, where I just did the first numbers divided by each other, and then I've subtracted the exponents over here. And down here on number 3B, it just said over here in the parentheses, it says 1 out of 100 of 1%. So I figured out the decimal for both of those numbers, and then made those into scientific notation over here, and then I just multiplied those, and I got 1 times 10 to the negative 4th over here. And then I did that times 100, and I got 0.001 cent. On the bottom one was just the estimate, like why I thought that Mr. Smith was criticized and not Miss Jones. You can read that on the thing I turned in. Up here, it was just the percentage up there. So I did. I wrote down what was missing and what his annual earnings were. Then I just divided them by each other, and I did the kind of like what I did on this first one up here. I did the scientific notation and figured out what that answer was, which was 7 times 10 to the 3rd, and that's the actual number right there. And then to find the percentage, you just move the decimal places 2 places to the right, and that's 0.7% right there. And then I did the same thing on Mrs. Jones' earnings, and got 0.014%. So she actually had a lower rate of change, or like how much was missing. Then on C, I just said the actual answer. I just figured out on number 6, I just figured out the scientific notation of the, the bottom was the budget, and so I just divided foreign aid divided by the budget. That's what I did. And figured out the scientific notation right there. And then it ended up being 0.0054. Which, again, you move the decimal places 2 places to the right, so it's 0.54%. And 7, I just measured the dollar bill, which was 6.2 centimeters long and 2.6 centimeters wide. And on number 8, I just did what we learned in class. I turned it into scientific notation, and then I converted centimeters to meters, and then meters to kilometers, and then kilometers to a mile. And I did that math right here. I multiplied the top line and divided all that by the bottom line multiplied. Which ended up with, in scientific notation, 9.26 times 10 to the 5th. Okay. I did the same thing on number 8 to figure out how long a string of a billion bills was. I did the same math, and then I just divided the number I got by how many miles around the earth it is. Right there, that little bitty one right there. And that got me approximately 1.5. It was like 1.54. And then on number 9, not sure if I did this one right, to be honest, but I did the same kind of math that I did on the last two, and except on the last one where I put kilometers right there, or kilometers, I just squared that because squared miles, that's what you do, you square it. But now I realize it may not be right, so. But anyway, I got 2.59 kilometers, or kilometers, so so I still multiplied the top line and divided that by this multiplied, but instead of using 1.609 kilometers, I used 2.59 kilometers, because that was what it was squared. And I got 23,938.22. And then on number 10, let's see. Oh, I figured out how many seconds it took to count $1 right here. And it was just 5/10, or 1/2 of a second for each dollar. And then I just did the scientific notation of $24 billion, or 24, yeah, $billion. And then multiply that by 1/2, which ended up with 1.2 times 10 to the 10th seconds. And then I put that up here, and I converted the seconds to hours, and hours to days, and days to years. And I just did what I did up here, which was multiply this and divide it by this multiplied. And, which is down here. And I got 380.52. I did not write the unit. 380.52. Oh, years. It's already there. Years. And that's it.